We're going to do some graphing, and again, please, I apologize for my stylus if my points are not where they exactly should be when we do the graphs. So the first example is graph each function for the given domain. What this means is that your domain is right there, it's given to you. Because it is given, you don't connect the dots, because this graph wants just those specific points included, so we are not going to connect them. This is a discrete function because each ordered pair is separate, distinct, it is discrete. You can remember that maybe discrete dots. So let's take a look at this. So x is -2. If you remember from the last section, we need to substitute that value of -2 into the function right here. So you'll see -2 plus 6, which gives you the 4. And then your ordered pair, this is the column that we are going to be graphing, is -2, 4. Your x is -1. We substitute that in right here, and you get 5, -1, 5. And you'll notice you have the rest of your ordered pairs. And so this is what we're going to be graphing right here. So we have -2, so you're going to go to the left 2 and up 4, which is right here. -1, 5, 0, 6, 1, 7, and 2, 8. And that's what it would look like. If the dots were connected, what would the graph look like? It would just be a straight line. You can tell a little bit from y equals x plus 6. If you remember this plus 6, that is your y-intercept, which is where you have 0, 6. That's your y-intercept. And you'll notice that from one point to the other, it is going up 1 over 1, which is what you can tell here. Your slope here is 1 over 1 because of the x. In the second one, you have y is the absolute value of x. And again, it's given the domain, so you are not going to connect the dots. And remember, the absolute value of any number is positive. So you're going to substitute, x is -2, so that's going to get substituted right there. So the absolute value of -2 is 2. So your x is -2 and your y is 2. I'm going to substitute. The absolute value of -1 is 1. So your y is 1. Absolute value of 0 was simply 0. 0 was not positive nor negative. The absolute value of 1 is 1. And the absolute value of 2 is 2. So we're going to go ahead and graph your order pairs right here. So we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So if your dots were connected, what would the graph look like? It just looks like a V. Absolute value graphs make a V shape. They can be up or down depending on the sign. Now in this graph, it says y equals x squared. So you'll notice that there is no domain that's given. And because it's not given, you must connect the dots. And that's because you could pick different points than someone else. And you have to connect the dots to take into account the infinite number of x values that could have been chosen. Yes, you'll see that I did pick some, but you may not choose to use those. You could use totally different numbers, and that's why the line has to be connected. The reason that I like these 5 are because it gives me -2 and -1, so the graph will fall, in the negative side, which just gives you a better representation of what the image could look like. If you go back and think about the absolute value graph, that was the V, if we hadn't chosen any negatives, you would never know that the absolute value would have made a V because everything would have been on that right-hand side. It would have just been a straight line. So it's always a good idea to pick some positive and negative numbers. I typically just pick 3. I would probably pick these, but I'm going to pick 5 just to give us more practice. We'll also take a look at some different choices depending on what you're given. If you're given a fraction, you're not necessarily going to pick -2, -1, 0, 1, 2. And we'll talk about some better choices when we get to there. So let's take a look at what we have here. So we have y equals x squared. Remember to always substitute with parentheses, because the quantity of -2 squared is going to give you 4. If you did not put parentheses around there, you would get a different answer. So here you're going to have -2, 4. Quantity -1 squared gives you 1. Obviously 0 squared is just 0. Quantity 1 squared is 1. And the quantity 2 squared is 4. Now take a minute and see, do you notice anything with this graph before we start to plot these points? Remember, we are going to be working over here, and you might have noticed that you have some opposites here. And you have some here. And then you have this one, which is, as you'll notice, we have -2, 4. We have -1, 1, 0, 0, 1, 1, 2, 4. So you'll notice that this 0, 0 is the turning point. And so we are going to connect these. Oops, there you go. And that's what your graph looks like. This is called a parabola. Now over here, I just wanted a little reminder, y equals x plus 3 is the same as f of x equals x plus 3, which is the same as g of x equals x plus 3. The reason you'll see these in different formats is because if they are all on one coordinate plane, you can't have them all be called y, because they're all different graphs. So you'll see an f of x and a g of x. And the f of x and the g of x are just showing that they are functions. So now here you have y equals 2x, y plus 2x equals 4. It has to be in y equals format. Otherwise, this is going to be a little bit harder to figure out the y's are when you plug in the x's. So this just makes it a little bit easier. So you're going to, if you look here, you're going to subtract 2x from both sides. So these go away. You have y equals -2x plus 4. It also helps you realize that in this case you have a negative slope. So you're going to see this come up in our next couple practice problems. So I want you to work on this by yourself. Go ahead and pause the video, and then you can come back and see how you did. You should have had for your ordered pairs -2, -7, -1, -5, 0, -3. -3 is hard to see. 1, -1, and 2, 1. You'll also notice that each one from here to here is going up by 2. And then if you wanted to plot this, you'd have -2, -7. That's going to be down here somewhere. 0, -3, -1, -5, 1, -1. And 2, 1. And there was a domain given, so you weren't going to connect the dots, but it should look like that. Here are some practice problems for you to do. The questions are on the next page in the video. And I am going to take a look at one of these, which is number 6. And number 6 is y equals 1/2 x plus 4. So this is where we were talking about ordered pairs to pick. So if you have to choose your domain, would you necessarily pick -2, -1, 0, 1, 2? Maybe. I would pick -2, and I would definitely pick 0, and I would probably pick 2, and maybe even 4. And what is it that you might notice about these numbers as it relates to the function that's given? You've got 1/2. So I'm going to jump right to half of 0 is 0. So 0 plus 4 would give you that your y value is 4. Half of 2. So you have 1/2 of 2 plus 4. Well, half of 2 is 1, and 1 plus 4 is 5. And then you have half of 4. Half of 4 is 2. 2 plus 4 is 6. And then half of -2 is -1, and -1 plus 4 is 3. So the reason that I picked all of these even numbers is because 2 goes into all of those even numbers. If I had 1/3 or 2/3, then I probably would have picked -3, 0, 3, 6. Picking numbers that divide evenly with this fraction will make the work a little bit easier for you. Could you still pick -1? Sure. You're just going to have to deal with fractions, and that's okay. So on this page for practice, you can take a look at number 1, number 3, and number 4. And then you can also do 5, 7, and 9. Now remember, you have number 7 and number 1. You're going to turn that into a y equals problem. And be careful with your 3x minus y equals 1. In this case, I would add y and get 3x equals y plus 1. And then I would subtract 1 and get 3x minus 1 is y. My only concern is that if this problem here, if you subtract 3x first, you're going to forget that that's a negative y. So it just might be easier to bring the y over, like we did here, and then subtract the 1 to get your 3x minus 1 equals y. Just a suggestion.